So in our first video, we actually covered what the concept of density was. We talked about how density isn't just weight and it's not just space, it's the combination of the two. It's a comparison of the amount of stuff in a certain amount of space, or the amount of mass in a certain amount of volume. But we're going to practice calculating density a little bit more because that's an important skill for you to have. So we have our brass block that we used in our last video, and we have our triple beam balance, and that's how we're going to find the mass, and then we're going to use our ruler to find the volume. But as a refresher, remember, density has a formula, and the density is mass divided by volume. Mass we measure in grams. Grams is a measurement of mass in science. And we measure volume, in this case, because it's a solid, we're going to use cubic centimeters. Centimeters cubed. If we were measuring a liquid, it would be in milliliters, but we're not. We're measuring it in cubic centimeters. So we're going to remind ourselves how to do this. We place all of the beams on 0, our block on the plate. We use the largest beam first. Put it at 100. 200 is too much. We try our second largest beam. 20, 30, 40 is too much. Go back to 30. And then we're going to be precise with that front smaller beam that measures in individual grams. And we get to 138 grams. So we're going to write that down. We're going to write that it's the brass block. The brass block is 138 grams of mass. But that's only one part of the problem. We still have to find the volume. And remember, in math class, you've probably learned that volume is length times width times height. It makes no difference which order you multiply them in. You're going to get the same answer regardless. In this case, we're going to take our 3 measurements and type them into the calculator. Remember, when you're using your ruler, to make sure you're using the metric side, the centimeters. So it's 2.5 times 2.5 times 2.5. We grab our little calculator. 2.5 times 2.5 times 2.5 equals 15.625. So we're going to write that down. 15.625, and again, it's cubic centimeters. Now, in order to figure out the density, we have to put these two numbers in. 138 divided by 15.625. So 138 divided by 15.625 equals 8.832. 8.832. And remember, we cannot divide grams by cubic centimeters. It's not the same unit, so we leave it the way it is, sort of. And we say grams per cubic centimeter. Makes sense because it's the mass in the volume, or the stuff in a certain amount of space. Now, you can do that for any kind of cube or block. You can use it for this one, you can use it for this one, you can use it for this one. The problem is that when we're walking down the street and we see a dog, and we want to find the density of the dog, we have to know the mass and the volume. We could put the dog on a triple beam balance or some sort of balance, but we can't find his volume with length times width times height because he's not going to be a cube. Dogs aren't cubes, rocks aren't cubes. Most things that we run into in nature are not cubic. So we have to find another way to calculate volume. No matter what you're finding the density of, you always have to know the mass and the volume, but sometimes the way we find the volume is different. So we're going to use this rock, and this rock is not a cube. It's hard to see, I think, but it's not a cube. And in order for us to find the mass, we're going to do the same thing. So let's go ahead and do that. We're going to reset our balance to 0. Place the pebble. And we're going to try our large beam first. Oop, too much. We'll try our back beam. 10. 20 is too much. I'm going to go back to 10. And then we try the front beam. and we get it to balance at, oops, let me see if I can see that a little better. 3.5. So we have to add those two together. It's 10 plus 3.5, so 13.5 grams. We're going to write that over here. This is the rock, and the density is 13.5 grams. That's only the mass. Now we run into trouble. I can't measure the volume this way. Won't work. We have to use something called water displacement. It's pretty much what it sounds like. You're taking water and you're displacing it. So if my friend is sitting on a chair and I want the chair, I have to bump them out of the chair and I displace them. That's what we do when we're finding the volume of irregularly shaped objects. But we're going to use this graduated cylinder, and we have some water already in it. Remember, when you're finding a measurement in a graduated cylinder, you have to make sure it's on a flat surface. You want to lower your eyes to the level of the water, and in this case, it has 50 milliliters of water. I'm going to write that down over here. I'm just making a note for myself. So we have 50 milliliters of water. That's what we're starting with. Think about if you filled up your bathtub all the way to the rim and then you got in, it's going to overflow because you can't be in the same place that the water is. The water has to go somewhere. The same thing's going to happen now. So I'm going to carefully drop my rock into my graduated cylinder, and I'm going to check and see how much water I have. Now it says I have 53 milliliters of water. Now, I don't have 53 milliliters of water. I didn't add water to this. I added a rock. And because the rock is in there, it raises the water level by 3 milliliters. So there's a difference of 3 milliliters, and that's important. It's very important because here's what you might not know. 1 milliliter of liquid volume takes up the exact same amount of space as 1 cubic centimeter of solid volume. So we can just change them. So here, this 3 milliliters of water that went up is how much space the rock took up. And that means that the volume of the rock is 3 cubic centimeters. So we use water displacement to figure out the volume, but we still have to continue to calculate our density. So in this case, we're going to take our 13.5 divided by 3, and we get 4.5 grams per cubic centimeter, or mass per volume, stuff per space. Okay? Now, what's interesting maybe is that this is about half the density of the brass block. So those are the two ways we calculate volume, but density is really the same. So to recap, in order to find density, you have to know the mass and the volume. You're going to use a triple beam balance to find the mass, and depending on the shape of the object, you're going to use a different way or method for finding volume. If it's a cube, you're going to use length times width times height. If it's not a cube, like most things in the world, you're going to use water displacement to find that volume. Hopefully that makes sense.